Good morning, students. We are starting the day 22nd of March with series first lecture of the day for subject physics. Last time we have started chapter 13, which is EM waves and communication. We studied few common properties of EM waves because EM waves cover a wide range of frequencies. Depending on the wavelength, they can be grouped distinctly, and all these EM waves possess few common properties. So we studied a few last time. We will continue to study few more which are left before proceeding. So we will continuing with studying characteristics of EM waves. So EM wave is oscillatory disturbance in which electric and magnetic fields mutually perpendicular to each other in phase of same frequency propagate, and both fields are perpendicular to direction of propagation also. The energy is equally divided in both these fields. Few more is, since energy is possessed, electromagnetic waves are energy carrier. They transport energy from one place to another place. So they carry energy, they transport energy. Is one more property of electromagnetic waves. They are energy carriers. Other property is being fields perpendicular to each other. Also, both fields perpendicular to direction of propagation of waves. It is transverse in nature. The waves are of two types, longitudinal and transverse. EM is transverse type wave. Being transverse in nature, it shows different optical effects. One of the well-known effects optical shown by EM waves, they can be polarized. Polarization is one effect. You have to study this effect in 12th standard. Only remember, EM waves can be polarized. Only transverse type of waves have this ability, and hence EM waves can be polarized. This property of polarization has tremendous applications. The use of EM waves in communication. When we study the use of EM waves for communication purposes, will prolong this property. So these are few more. Being wave, they show all different phenomena shown by waves like reflection, refraction, diffraction, interference, etc. So they transport energy, they can be polarized, they are transverse in nature, they show different phenomenon, or they show or they obey principle of superopposition. When two or three or more than that waves pass through the same medium, Each wave passes independently. They do not depend on each other. So they obey the principle of superposition. These are few more characteristics shown by EM waves. So we have completed the discussion on characteristics of EM waves. At the time of Maxwell, EM waves corresponding to visible light were only known. By the end of 19th century, that is 1830 to 1899, X-rays, gamma rays, which are again of EM waves, were discovered, and at present, along with these all, few more, that is radio waves, microwaves, infrared waves, are detected and are prepared. So, actually, natural source of EM waves is sun. Sun emits different EM waves of wide range of frequencies. Till now, we are able or we have detected only this type of waves emitted by sun. We are able to produce these waves in laboratory, that is in artificial method. There are so many electronic waves emitted by sun which are not still detected by us. So you have tremendous scope of research to study radiation emitted by sun. So at present we are able to detect only the definite range of EM waves emitted by sun. Also these waves in the given range can be artificially produced in laboratory. So what happens? These EM waves have different values of wavelengths. That is different values of frequencies, because in air or free space or in vacuum they travel with same speed, equal to speed of light. So all EM waves even have different wavelengths or frequencies, travel in air with same velocity. Depending on the wavelengths of frequencies associated with different EM waves, they show distinct properties from each other. When you consider orderly distribution of these EM waves, at present you get different regions. So orderly distribution of EM waves according to their frequencies or wavelengths is called EM spectrum. So we will switch over now to study what is EM spectrum. So radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, gamma rays, all these are electromagnetic waves. If these known EM waves, still few have not yet detected, but out of known, if you arrange them in order, orderly distribution according to their frequency, means lowest frequency at one end and highest frequency at the other end. So lowest frequency wave has larger wavelength and higher frequency has shorter wavelength. If you arrange them, you will get different regions. These regions have not distinct boundary. there is overlapping in between the two regions, but still, depending on the values of wavelength, they can be arranged. This arrangement is only useful to study energy distribution amongst these waves. Few waves of very high frequency are highly energetic, and few EM waves comparatively lower values of frequency, they have energy but still to smaller extent as compared to the waves at up end of the EM spectrum. So out of entire EM spectrum has two parts, visible light or visible range. They have particular value of wavelength. The EM waves of wavelengths less than that of visible light or greater than that of visible light cannot be seen with our naked eye. For example, microwaves, radio waves, infrared rays, ultraviolet, X-ray, you cannot see. So you see only that part of AM spectrum, visible light. Visible light produces sensation on our retina. This much part only is visible for us. So you can divide the entire EM spectrum in two parts, visible light range, the wavelength below and the wavelength above. So the wavelength of radio waves is largest out of all known EM waves at present, and it lies at 1A. Microwaves have a little smaller wavelength in comparison with radio waves. So next region is microwaves. Infrared rays have wavelengths between visible light and microwaves. So this infrared lie in between these two, visible light and microwave. Beyond visible light, the waves having a little higher frequency than visible light are ultraviolet rays. Ultraviolet is followed by X-rays and last is gamma rays. So even they are called as rays, they are not light rays. They are the part of EM spectrum. They are electromagnetic waves. So ultraviolet X gamma have very high frequencies. Radio, micro, infrared have comparatively lower frequencies, higher wavelengths in comparison of wavelength of visible light. So at present, EM spectrum has 7 different regions. In increasing order of frequency, if wavelength decreases, frequency will increase. So largest wavelength these radio waves possess. Radio wave, microwave, infrared, followed by visible, then ultraviolet, X-rays, and last is gamma rays. Gamma rays are EM waves having largest frequency, highest frequency, and hence very rich in energy. Their energy content is very, very high. But the exposure of human being or any living organism for very high range EM waves is injurious, is dangerous. So you should not expose ourselves to these rays. Visible light you can tolerate. Human being doesn't affect much for visible light. But the light which has smaller, larger wavelengths, radio, micro and infra, they are not visible for human eye. We cannot see them directly. So visible light is useful for us to observe different effects or to observe the objects in our surrounding. Which are non-visible are these three and these three. But these three are very dangerous for our health. So you need not go for the upper part of EM spectrum. We will focus the lower part of EM spectrum till visible light region. Being very short frequency wavelength or waves, they are much useful for human beings. So these radio waves, microwaves and infrared along with visible is usable part of EM spectrum for us. Gamma rays can be produced. X-rays, ultraviolet rays can also be produced, but the exposure to this is very injurious or is very dangerous. So, we should give least exposure of any living organism for this region, So, remember these all points well. The properties and uses of gamma, X and ultraviolet rays are deleted for this year from your portion. No question will be asked to state properties or to state uses of these three. In our syllabus of this year, only these four regions are included. So we will move further to study the characteristics of each region. So the radio waves having a little higher frequency, a little lower wavelength, and the initial part of microwaves, they overlap. There is no sharp boundary, but still each region shows certain distinct properties, and hence we can study their use. So radio waves are the electromagnetic waves possessing largest wavelength out of known electromagnetic waves to us at present. They show some peculiar property other than micro, infra or visible light. So we will start with radio waves. Radio and micro both are having lower frequencies. So you can use them or you can study their characteristics together. Only microwave have one peculiar characteristics, that is directional property. Radio and micro both we will study simultaneously. What happens? Radio waves emitted by Earth of comparatively higher frequency, lower wavelengths, nearer to microwave region, can pass the atmosphere and enter in the space. Similarly, microwave can also pass atmosphere and enter the space, but they don't get much deviated. And lower part of radio waves of largest wavelength, they get reflected back from the layer of atmosphere. So these three distinct properties are used to use these radio waves or microwaves for telecommunication purposes. Radio waves get reflected back while microwaves can pass across the atmosphere and can enter in space. So in satellite communication through satellite, these microwaves are used, especially they are used in radars. जो रडार है ना, डिटेक्ट करते हैं आजू बाजू क्या है चल रहा है, उसमें माइक्रोवेव्स यूज करते हैं because they can pass through atmosphere and they don't get deviated during their propagation. रेडियो वेव्स में दो रीजन्स हम लोग डिवाइड कर सकते हैं, having larger, comparatively larger wavelengths far away from microwave region are reflected back. Nearer the microwave region are can escape in space. So this part is very useful for communication purposes, for telecommunication purposes. So radio and micro especially are used for telecommunication purposes. The use of microwave and radio wave for telecommunication again is classified into different parts. So this is radio and micro. What about infrared rays? These infrared rays get absorbed when pass through atmosphere surrounding the earth, and hence even have larger energy, cannot be used for communication purposes for far distances, for long distances. They are used generally for short range communication. For example, your TV set remotes. आपने रिमोट्स होते हैं, जब भी ऑन ऑफ करते हैं तभी we use sorry for the disturbance, we use this infrared region. So infrared region are used only for short communication. Their range is very small. So generally infrared are used in remotes of TV. जो रिमोट्स है ना, कौन से भी रिमोट्स, उसमें ज्यादातर इंफ्रारेड रेज का इस्तेमाल किया जाता है. And radio and micro for telecommunication, long distance communication, global communication. So global communication is through satellite, and for satellite communication this radio and micro are used. So radio have largest wavelength, followed by microwaves, followed by infrared rays, and then is the visible light. This is the lower part of EM spectrum. Radio waves and microwaves are not much harmful. They are non-ionizing type, and if exposure of human body, they do not have much effect on any living organism. This is one more property of radio and microwave. Infrared rays, what happens? Microwaves और क्या अलग है रेडियो वेव से? When microwaves show, they get absorbed by water molecules. Microwaves में हम लोग करते हैं ना रीहीटिंग, जो हम लोग फूड तैयार करते हैं घर में, वो रीहीट करते हैं, माइक्रोवेव का इस्तेमाल करते हैं. So microwaves are the waves having a little higher range frequency as compared to radio waves, and they show certain peculiar property other than radio waves. So microwaves are used as heating agents, but वाटर मॉलिक्यूल्स एनर्जी एब्जॉर्ब करते हैं, मैक्सिमम उनका आयोनाइजेशन होके उनका एम्पलीट्यूड बढ़ता है और इसलिए फूड अपना ज्यादा से ज्यादा गर्म हो जाता है. सो माइक्रोवेव्स are used there, not the radio waves. Radio waves में ये प्रॉपर्टी नहीं है. They cannot produce heat. They are not absorbed by water molecules. Water molecule content जो है ना, वो माइक्रोवेव को एब्जॉर्ब कर लेता है, उसकी एनर्जी एब्जॉर्ब कर लेता है. सो इसीलिए खाना पकाने के लिए जो माइक्रोवेव ओवन यूज करते हैं उसमें हम लोग माइक्रोवेव्स का यूज करते हैं. रेडियो वेव्स दैट टाइम यूजफुल नहीं है. इंफ्रारेड रेज का प्रॉपर्टी क्या है? दे get absorbed by glasses, especially glass material, and they do not show the heating effect. वो एलिमेंट जिसपे इंफ्रारेड अटक जाते हैं, इंसिडेंट हो जाते हैं, वो इंफ्रारेड एब्जॉर्ब करते हैं, इनकी एनर्जी एब्जॉर्ब करते हैं, बट दैट पर्टिकुलर सब्सटेंस डज नॉट गेट हीट और हीटेड मच. सो इंफ्रारेड और सोलर एनर्जी है ना, उसमें अबाउट 60% ऑफ इंफ्रारेड्स आर प्रेजेंट. आउट ऑफ 100% सोलर एनर्जी emitted, 60% is in the region of infrared. सो जहां जहां सोलर का इस्तेमाल किया जाता है ना, वहां इंफ्रारेड रेज काम करते हैं. इंफ्रारेड रेज गेट एब्जॉर्ब लेकिन सोलर पैनल जो हम लोग यूज करते हैं ना, वो सोलर पैनल में भी इंफ्रारेड रेज जो सन से आते हैं वो सोलर डायोड्स एब्जॉर्ब करते हैं एंड यू कैन यूटिलाइज दैट एनर्जी. सो इंफ्रारेड शॉट अ पेक्यूलियर प्रॉपर्टी ऑफ एब्जॉर्प्शन बाय सर्टन ग्लासेस स्पेशली ज्यादा एब्जॉर्ब करते हैं और इसलिए वो ग्लासेस सोलर पैनल्स, नहीं तो शॉर्ट डिस्टेंस कम्युनिकेशन मैंने बोला ना, जो टीवी के रिमोट कंट्रोल है उसमें भी इंफ्रारेड रेज ही यूज किए जाते हैं. एंड विजिबल लाइट तो आप सब लोगों को मालूम है, टू ऑब्जर्व डिफरेंट इफेक्ट्स, टू नोटिस द ऑब्जेक्ट सराउंडिंग अस, दिस विजिबल लाइट range is useful. So radio and micro especially used for telecommunication. Micro has one more peculiar property. They have directional property. They don't get deviated from the original path if there is no obstacle in between their path. They can go to space also by crossing this atmosphere. So these are used for satellite communication or to detect any object in the space also, not only in the atmosphere but like in space also, in radars. So in radars or in global communication, satellite communication, these microwaves are used. And radio waves are generally used for radio broadcasting and telecommunication, not over the global but short range. So these have few properties of different regions till visible light, that is lower part of EM spectrum. With this specification, we will study their uses. We will go further to study the uses of these different EM waves for our purposes. So we have switched over. So peculiar properties I have told you. These are listed nicely in the book. Properties of each part or each region of EM spectrum along with their uses separately. So distinct properties है. Infrared rays, short distance communication, they produce or they get absorbed, but that substance does not have the feeling of heat, their temperature does not change. So एनर्जी तो एब्जॉर्ब हो जाती है लेकिन टेम्परेचर राइज नहीं होता है, इसलिए सोलर पैनल, नहीं तो वो जहां हम लोग ब्लैक एंड व्हाइट कैमरे यूज करते हैं ना, वो उसमें भी इंफ्रारेड रेज, नाइट शूटिंग स्पेशली इन डार्क्स, कॉन्ट्रास्ट उसका ज्यादा अच्छा है तो उसमें इंफ्रारेड कैमरे यूज किए जाते हैं. So we now will switch over to study the uses. So I have already told you radio waves and microwaves do not harm to our human body. If you expose for radio and microwave, National Cancer Institute has not recorded yet the consistent effect on human body when exposed to radio and microwaves. So this radio and micro is most useful part for practical purposes for human life. They are widely used. They are easily available. They can be easily produced. The other property of radio waves can be easily produced. They are non-ionizing radiations. उसमें ionization नहीं है. सो नॉन आयोनाइजिंग रेडिएशन से इसलिए बॉडी के लिए, ह्यूमन बॉडी और एनी लिविंग ऑर्गेनिज्म के लिए वो हार्मफुल नहीं है. येट नेशनल कैंसर इंस्टीट्यूट हैज नॉट डिक्लेयर्ड इट्स इफेक्ट, इट इज वेरी इंजूरियस वगैरह ऐसा नहीं है. सेलफोन में भी हम लोग रेडियो वेव्स यूज करते हैं. अगर इंफ्रारेड रेज ज्यादा यूज किए सेलफोन में तो दे विल प्रोड्यूस हीट and our brain will get damaged. So infrared rays are used only for short distance communication or to produce heating effect. Microwave especially space में भी जाते हैं without deviation. So especially they are used in radars. Radars में उनका ज्यादा उपयोग होता है और elsewise for global communication, जिधर सैटेलाइट कम्युनिकेशन है उसमें माइक्रोवेव ज्यादा से ज्यादा यूज किए जाते हैं. And these micro radio are easily producible. You can easily produce them, non much injurious. They are non-ionizing type radiations, and hence only the part of radio or microwaves lying within 30 hertz to 300 megahertz. This much range of radio waves is only much injurious. Otherwise, radio waves are not harmful much. So they can easily transmitted. They don't produce any damage, and they can be reflected by atmosphere to change their directions. These property are ideal for communication purposes. So tomorrow we will study the use of radio and microwaves for telecommunication purposes. So now the time is up. I am closing the meet for everyone. Thanking you all to be present. So tomorrow we'll continue the use.